7b, finding the absolute maximum and minimum on a closed interval. Find the critical numbers of f that lie in the open interval. Compute the value of the function at every critical point found in step 1, and also compute f of a and f of b. The absolute maximum value will be the largest found in step 2. The absolute minimum value will be the smallest found in step 2, and that's just too many words for me to actually work the problem. So, it says find the absolute maximum or minimum. The first thing I do is I notice I'm between -1 and 1. So I draw my t-bar chart and I put -1 and 1. Those are my endpoints. And it includes the endpoint. Now where you'd have an open is if it did not include the endpoint. It includes the endpoints. So then I need to find what goes into here next are basically my critical numbers. Critical values, those are, and this is x and y, those are my maxes and those are my potential, those are my relative maximins. Those are your humps and your valleys. So what are we going to do? We're going to take the derivative, set it equal to 0, and we have a greatest common factor of 60x cubed times x squared plus 2x plus 1. Is that not the cutest thing? See, I don't care about multiplicities now. Why? I'm not looking for increasing, decreasing, concave up, concave, and I could care less. I just want to know what are my critical numbers. And this says that x equals 0, and this is x minus 1 squared equals 0, x equal 1. So I have two critical numbers, and those two numbers, if both of them are in between -1 and 1, great. If they're not, then you don't include the one that's not in the interval.
It's supposed to be x plus 1.
Yeah.
X plus 1. Oh, that's going to be a -1. Thank you. That's going to be a -1. So notice this is the end point of the interval, so I'm fine with this guy, and 0 is there. See, I don't care that -1 is a relative maximin. This thing gets chopped off at -1. So it's whatever that value is. So now I come down and I'm going to calculate out in the original function. I need to know what is f of -1, what is f of 0, that's the easy guy, f of 0 is 3, what is f of 1. And I do have these already calculated out. So f of -1 is 4, and f of 1 is 52. Now all I do is I look at the y values. What's the biggest? That's your absolute max. What's the smallest?
3.
That's your absolute min. They are y values. So I have an absolute max. Absolute max is 52. You could write it this way, at x equal 1, but absolute max and absolute min is a y value. And the absolute min is 1, or I'm sorry, is 3 at x equals 0. So they're y values. That's something you need to remember for the exam. They're y values. Now, it could repeat, so you could have it more than, it could occur more than once. So, ooh, this is interesting. X is greater than or equal to 0.
Less
I don't like it written that way. Little pointy thing always points to the smaller number, or the alligator always eats the bigger. So it starts at 0 and goes to infinity. Interesting. So first thing I need to do is take the derivative, set it equal to 0 to get critical numbers. And that says that negative 2 equals 0. That can never happen. So there are no critical numbers. Well, x can't be negative 1. However, what is x equal negative 1? Oh, I'm sorry. What is x equal negative 1? Look at the original problem. What is x equal negative 1? F of x equals x plus 1 to the negative 2, which is the same as what? 1 over x plus 1 squared. So what's negative 1? For a VA. So do I have any critical numbers? No. So I need to put 0 in, and 0, that's 1 to the minus 2. What's 1 to the minus 2? 1. Yeah. 1 to the minus 2. Or put 0 in here. What do I get? 0 plus 1 is 1. 1 squared is 1. 1 divided by 1 is 1. Then I have this guy. Now what am I going to have to do with him? I may not have any, I may have maxes or mins or nothing at all. What am I going to need to do if I'm looking at infinity?
Limit.
Take the limit as x goes to infinity of 1 over x plus 1 squared, which goes where? To 0. But is it ever 0?
No.
No. So that says, is 1 bigger than 0? Yes. So this is my absolute max. And there is no absolute min. And you're going to say, well, how do you know that that's an absolute max? Are there any other critical values? No. So that means that's the biggest this sucker's ever going to get. Because there's no humps or valleys to outweigh it. And if I take the limit the other direction, it's still going to be 0. But I don't care what it does on the other side. I'm care between 0 and infinity. Between 0 and infinity, this sucker is going. So, absolute max of 0 at x equal, or of 1, I'm sorry. 1 at x equals 0. We need to make that prettier so it's not a complete blur here. One at x equals 0, and no absolute min. Interesting.